Hi all, very good morning. Today we are going to learn the concepts of Java. Now, what is Java? So, Java is a programming language and a platform. It is high level, robust, object oriented, and secure programming language. These four are the features of Java buzzwords again. Now, what is platform? Right, any hardware or a software environment in which program runs is known as a platform. Since Java has a runtime environment JRE and API, it is called as a platform. Okay, so Java can be explained in a simple way, which can be elaborated as C++ minus minus plus plus. So what is C++? Includes the concepts of C++. Minus minus indicates there are few removed confusing concepts in Java. Those confusing concepts are pointers, operator overloading, multiple inheritance, and so on. And last plus plus indicates newly added concepts, which are AWTs, applets, GUIs, swings, right? So these are the features which are included in Java. So now what is history of Java? So when it was invented, what is the purpose of its invention, and what actually was the history of that Java? We are going to learn here. So Java was originally designed for interactive television, but it was too advanced technology for digital cable television industry at that particular time. So the history of Java starts with a green team. So what green team is? There are five members in terms of a team, right? Those five members are called as a green team. So you can see the team of five members here, right? So James Gosling, Patrick Norton, Ed Frank, Chris Worth, and Mike Sheldon. So all these five members are called as a green team. So Java team members, who are also known as green team, they have initiated this project to develop a language for all the digital services such as set-top boxes, televisions, etc. However, it was best suited for only internet programming. Later, Java technology was incorporated by Netscape. Okay, so Java was developed by Sun Microsystems in the year 1995. So it was invented by a team of five members, but James Gosling is known as father of Java. So here right side, it indicates a tree which is called as oak tree. Okay, what is the speciality of this oak tree? Why we have just put this post here? Just let us learn. Okay, so firstly, it was called as Green Talk by James Gosling. Okay, and the file extension for that was .gt. See, generally we have file extensions. So for C language, you will be having .c as my file extension. For C++, you'll be having .cpp as my file extension. For Java, you'll be having .java as your file extension. In the same way, here, for this Green Talk, the extension was .gt. Is it point clear? So now, when Java was developed, it was by name Oak. This Oak was given in the year 1960s, right? So James Gosling and his team members have changed Oak to Java, right? So why Java was named as Oak? That is a question, right? So why Oak? Now, just generally, when you come across oak is a symbol of strength, chosen as the national tree for many countries like USA, France, Germany. So, as these people belong from those places, they have just given the name of that Java as oak initially. That is in 1960s. Then later, in 1995, oak was renamed as Java because it was already a trademark by Oak Technologies. Is it point clear? So now, why Java programming named as Java? Right, that is a question again. So the team gathered to choose a new name. Right, they have suggested few things. A language should be in such a way that it should be dynamic, it should be revolutionary, it should be self, right? It should be jolt, DNA, etc. They wanted something that reflects the essence of technology, right? So revolutionary, dynamic, lively, cool, unique, and easy to spell and very fun to say. So they have chosen this language as Java. This is the reason. And next thing is, what is the need of oops paradigm, right? So why we are using this oops? What is the purpose of that? How we are going to approach with that, right? So the main necessity behind inventing object-oriented approach is to remove the drawbacks of procedural approach. So if you take an example of C++, we are going to follow some procedure, right? So in order to, whatever the drawbacks we are encountering with that procedure-oriented language, to overcome them, we have been given with this OOPS paradigm. So the programming paradigm object treats data as an element in the program development and holds it tightly rather than allowing it to move freely around the system. So in terms of C and C++, data is not that freely moved, right? So that's the reason why they've taken the concept of Java where data can be freely moved. Okay. What it will do generally, it ties the data to a function that operates on it and hides protects it from accidental updates by external functions. Now, object-oriented programming paradigm allows decomposition of system in number of entities called objects. So we are going to divide a system in terms of object. And what I do is, whatever the properties are there related to that class, I'm going to bind them to that particular objects, whether it is instance variables, whether it is a method, whether it is the object, right? Whatever it is, okay? There are some features in Java like constructors we can use, inheritance, right? Nested class, properties, static instance variables, methods. All these can be just used in terms of object. So all these can be tied in object, okay? Now, an object properties can be accessed only by the functions associated with that particular object, but functions of one object can access the functions of other objects in the same cases using access specifiers. So we have three access specifiers, right? Public, private, and protected. Using those access specifiers, we are going to use, right, the functions which are used in one object can also be used by other objects as well. I mean, we can access the properties. Now, the software produced using object-oriented programming paradigm is easier to adapt for the changing requirements, and it is easier to maintain. It creates the modules of functionality. It promotes the greater design, and it is robust and performs a desired work efficiently. You can see, fine. So the object-oriented techniques they'll just work more efficiently on traditional techniques due to the following reasons. Why? The first thing is the high level of abstraction. So what is abstraction? Generally we have abstraction is nothing but hiding of data, restriction of data, right? So generally top-down approach supports abstraction at a functional level, while object-oriented approach supports abstraction at object level. Okay. Now, next thing is the seamless transition among different software development phases. It uses the same language for all the phases, which reduces the level of complexity and it just reduces the redundancy problem and makes the software development clear and robust. So complexity is reduced, redundancy, duplicacy, right? Redundancy is nothing but duplicacy that also can be reduced. Now, next thing is it's a good programming practice. The subroutine, okay, or subprocess and attributes of a class are held together tightly. Now I can say routines are nothing but functions as well, right? So the functions and attributes of a class are held together. Now it improves the reusability. The main purpose of working this with this object-oriented paradigm is it improves the reusability. Perfect code reusability is done in this. It supports inheritance, due to which classes can be built from each other. So only difference and enhancement between classes need to be designed and coded. All the previous functionality remains as it is and can be used without any change, right? So now let us learn the concepts of differences between C++ and Java. See, C++ is also object-oriented programming language. Java is also it is also an object-oriented programming language, right? So now what is the difference between these two, right? Let's learn here. So generally C++ is called as partial object-oriented programming system. whereas Java is called as fully object-oriented programming system. Now I've just differentiated, I've listed few differences between the C++ as well as Java. As we have seen in our first slide that Java can be elaborated as C++ minus minus plus plus. So there are some concepts which are removed from C++, and there are some concepts which are newly added in Java. So that is the difference we are going to just check here. Okay. Now you can see the first one, comparison index. This is platform independent. Okay, for C++ as well as Java. Now generally C++ is platform dependent because the program which is written on one operating system that can be executed in that operating system itself. Whereas coming to Java, it is platform independent, right? So the program written on one operating system can be executed in any of the operating systems. So why this is platform independent? That is because of presence of bytecode. What is bytecode? That all we see in the coming slides. Okay. So what is the next concept is it is mainly used for system programming in terms of C++. Whereas in Java, we can develop application programming as well. So we can develop two types of programmings here, window based as well as console based. Is it point clear? So now what is a design goal? C++ was designed for systems and applications programming. It was an extension of the C programming language, right? So now Java was designed and created as an interpreter for printing systems, but later it has extended as a support network computing. It was designed to be easy and accessible to the broader audience, right? So now go to statement, which can be used in C++, and Java does not support that go to statement. Again, there are few more differences. Multiple inheritance. Okay, this multiple inheritance, C++ supports this multiple inheritance, whereas Java does not support multiple inheritance. So why it does not support multiple inheritance? And what is the concept which supports multiple inheritance that we are going to come across in the coming classes. Now, this is all about one point that interfaces are used to work with this multiple inheritance in terms of Java. Okay. Now, operator overloading. What is operator overloading? Name itself suggests overloading. We are using multiple times, right? So same operator can be used multiple times for different purposes or for performing different operations. So that concept is operator overloading, which can be supported in C++, but it can't be supported in Java. Is it point clear? That is one of the removed concepts in Java. Now pointers, generally pointers are confusing concepts, right? So the C++ supports these pointers, whereas coming to Java, it does not support pointers, right? It supports internally itself. However, you can't write that pointer program in Java, right? Why? Because that's the reason why it is restricted. Pointers are restricted in Java. Next point is the difference between the compiler as well as interpreter. Now, what is compiler? What is interpreter? Both of them are used to convert the program from one language to another language, in the sense from high level language to low level language and vice versa. Now, compiler will do the same thing, interpreter will do the same thing. Then what is the difference between these two? Interpreter, where it compiles the program in step by step, whereas coming to compiler, it compiles the program all at once. So we'll be using the concept of compiler to compile the program. Now C++ uses compilers. C++ is compiled and run using the compiler, which converts source code into machine code. So C++ is platform dependent. Okay. Now coming to Java, it uses both compiler as well as interpreter. Is it point clear? So now you can see what is compiler and what is interpreter in terms of Java. So interpreter, JVM, is called as interpreter, whereas JIT, just in time, is called as compiler. Okay, these two we are going to use in terms of Java. Next is call by value and call by reference. Reference is nothing but an address. So address generally can be worked with the help of pointers. As pointers is completely removed from Java, right? So this call by reference is also removed by this call by reference is also removed in terms of Java. Now C++ supports both call by value and call by reference, but Java supports only call by value. Now, structures and unions, which are one of the important concepts of C and C++, those are there in C++, but Java does not support structures and unions. Now, thread support. Thread is nothing but a process. So we have a concept of multi-threading, right? Where this multi-threading is not supported in terms of your C++, but Java has built-in thread support. Now, documentation, okay. Generally, we are using to generally we are going to use comments, right? So C++ does not support documentation comments, whereas Java supports the documentation what is that comments? Fine. So this is all about the differences. Again, the virtual keyword, C++ supports virtual keyword, right? And then whereas Java has no virtual keyword in this. Okay. Then C++ does not support shift operators, whereas Java supports unsigned right shift. Okay, so these are few differences between C++ and Java. So now, before working with a Java program, first of all, I need to set a path. Okay, generally we will be terming it as class path. So how you're going to set a class path to execute your program? So I have two ways declared here, right? So one is how you're going to set the class path in two ways. First way is temporary, second way is permanent. Okay. So in order to work with any of the Java program to execute them, I need to set a class path or a separate environment. Okay. So wherever we are going to just install our JDK, there we are going to have a bin directory, and that bin directory path should be set in terms of your class path so that we can execute the program easily. Is it point clear? Now you can see how to set the temporary path for JDK in Windows. Right, to set a temporary path of JDK, you need to follow the steps. First, you need to open the command prompt. Second, copy the path of JDK bin directory. Right, you will be just installing JDK, right? So wherever that JDK is installed, open that JDK. In that JDK folder, you'll be having bin directory. Take that and copy the path. I'll show you in terms of a screenshot as well. Okay, write that in command prompt where you're going to use this variable called set path. Set path is equal to whatever the path you're going to copy, that path you're going to save. Okay, they're going to paste here. Now, for example, this is environment variable set path equals to my JDK folder is present in C drive, that is in programming files. Okay, right? Then in terms of Java folder, in that we have this version of JDK, in that we have bin directory. That is copied, you're going to paste in the command prompt. I'll show you. Now you can see here. So you're going to take, see, initially in order to compile a Java program, I'm going to use a command called Java C. Now when I use Java C without setting a class path, I'll get an error like this. Java is not recognized as an internal or external command. So what I do, I'm going to set the path. So this is a variable I've taken. This is C drive. Program files is the folder. In that Java is present and JDK version followed by bin directory. I'm going to copy here. Once it is copied, once the path is set, then when I say Java C simple.java, so you can see here, you got Java C is not recognized, but after installing the class path, you got Java C. If you work with, there is no error. Directly you can compile the Java and you can run the Java program. This is temporary mode of working with Java program or setting a class path. Now, if you come for the permanent path, every time you can't set the class path, right? So I need to just save it for permanent and I can continue with the execution of my programs. Now, for setting the permanent path of JDK, these are the steps you need to follow. First, go to my computer where you can be seen on the screenshot, right? Right click on that. Then in that, you're going to have the properties. My computer, in that you're going to have properties. At the end, you can see here, right? Then afterwards, you have advanced tab. Once you go inside to this properties, you'll be finding advanced tab. Okay. Then in that, you're going to select environment variables. Then you can use new tab for user variable. Then you're going to write the path in that variable name. Then write the path of bin folder in variable value, and just you need to press OK, OK, and OK. Then path is set for permanent. Now I'll show you in terms of your screenshot. Please try this and you can execute the program easily. Fine. So no need to just set the path every time. This is enough if you set for the first time. Clear. So now go to my computer. That is my first step. And second step is click on advanced tab. So you can see advanced system settings. Click on this tab. Then you'll be taken to this system properties. In that system properties, you have this advanced tab. In that, you are going to find environment variables. So click on that environment variables. There, you are going to come across this screenshot where you're going to just click on this new. Once you click on view, a separate tab will be opened. Okay, in the tab, the variable name should always be path, and variable value should be the path which you have copied. I'll show you. So here you can see my Java folder. Once it is installed, my JDK that is installed in local disk. Then you have program files. Then you entered into Java. Then you have JDK version and in bin. So you are going to just copy this address and you're going to paste in this variable value. Variable name is path. Variable value is this one. And you need to press OK. Then afterwards again OK. Then afterwards again OK. Now the path is set, right? Now your permanent path is set here. You can now execute any program of Java from any drive. Is it point clear? So this is how you're going to work with the installation of class path. Okay. Now you have editors of Java, the next step. So why generally we use these editors? So in order to interact with any of the programming language, we use these editors, right? So editors, it is very clear here. It is provided for interaction of Java, okay, which are called as IDEs, integrated development environments. So following are the different editors which are provided to interact with Java. So we have JBuilder, JDeveloper, Java Fort, Visual Kei, right? Then you have Kava, Macromedia, Eclipse, right? So to interact with this Java and its IDEs, resources like capacity of RAM, hard disk, processor should be good, right? You'd have very good resources of that, good memory, so that it won't be the program execution won't be slow. Clear. Now, always I say Java is platform independent, right? Why it is platform independent? What is the reason why this Java has become that platform independent? Which feature made this Java as platform independent? That is the question, right? So bytecode. Because of presence of this bytecode in Java, that made Java program as platform independent. So generally what happens when you create a Java program, it compiles that Java program. Once Java program is compiled, a bytecode is generated. Now what is bytecode? Right. So it is neither an so generally bytecode is termed as intermediate code, which is nothing bad. It's neither an object code or it is not a complete executable code. It is an intermediate code. So when bytecode is generated by this Java compiler, that program that makes the program to act as platform independent. To interact with the generated bytecode, Java provides a runtime environment or a runtime machine called as JVM. Okay, so JVM will generally interacts with your bytecode. So now JVM acts as interpreter, okay, where it executes the bytecode in step-by-step procedure and translates that bytecode to pure object code. To overcome this drawback, that is step-by-step procedure, Sun Microsystem has introduced a new runtime environment with a version Java 2.0 called as JIT, just in time, which acts as your compiler. Is it point clear? So here it acts as your compiler. Okay, this JIT acts as a compiler and provides the first execution of a program. Now, this is the structure of Java program. So class name. You can take usernames here. You can take any of the names, user required names or inbuilt names, right? So I'll say you class name. I can give my class name as class Raj, class, whatever the name you want, your user required names, your names also you can give here, right? So this is the main function. Generally in C and C++, we'll be restricted only with void main. We'll be writing only void main. But whereas according to structure of Java program, we need to work with all this public, static, void, main, string arguments. Now, what is public? Public is an access specifier. So what is static? It's a keyword. Void, it's a return type, which is called as null data type as well, which does not return any value. Then main is a function. Then you have string is a class. Then you have arguments is an variable, array variable, right? So now, as coming to the concept of data type, you have char, right? Character data type in terms of C and C++ provides only 1 byte of default memory, whereas coming to Java, it provides 2 bytes. Because, see here, in C language and C++, it interacts with ASCII code concept. Okay, whereas in terms of Java, it interacts with universal code, which is Unicode. Okay, so now whatever the input you give in Java, that can be by default of string type. Okay, so I need to convert these strings into respective data types. That can be done with help of some wrapper classes that we are going to learn in coming classes. Generally, you have wrapper classes like integer.parse and character.parseChar, float.parseFloat, string.parseString we won't be having, because every input which you give, that will be in the form of string. So you can't convert again that into string, right? So, okay, that we'll see in the next class. Now you have this declaration part, execution part, where you're going to declare the variables and you're going to execute them. This is a simple structure of your Java program. Now, features of Java. Generally, these features made this Java a famous language. These features are also termed as Java buzzwords. We have 12 buzzwords. Okay, so you can have a list of all these 12 buzzwords. The main thing or the main objective of Java programming language creation was to make it portable, simple, as well as secure. Right. So apart from this, there are also some excellent features. Generally, those play an important role. Those are called as features of Java, which are also termed as Java buzzwords. Okay. Now we are going to learn these Java buzzwords individually. Okay. So we have all these features. The first one is object-oriented, simple, secured, platform independent, robust, portable, architectural neutral, dynamic, interpreted, high performance, multi-threaded, distributed. So these are all called as Java buzzwords. Each and every buzzword have its own speciality. Now let us come with the first one, that is object oriented. So what generally this object oriented is, right? Java is very simple to learn, and its syntax is also very simple, clean, and it is easy to understand. According to Sun Microsystems, what happens is Java language is simple programming language because Java syntax is based on C++. So now in object-oriented, Java is an object-oriented programming language. Everything in Java is an object. Object-oriented means we can organize our software as a combination of different types of objects that incorporate both data and behavior. The basic concepts of OOPS are abstraction, polymorphism, encapsulation, inheritance. Okay. And for all these, you're going to use two again building blocks, which are called as class and object. So that is one of the concepts of your object oriented, right? And next is you have simple. So generally name itself suggests what is simple. Java is very easy to learn. Okay, Java syntax is based on C++. Java has removed many complicated and rarely used features. For example, operator overloading, pointers, etc. Right? There is no need to remove any unreferenced object because there is an automatic concept called garbage collection in Java. That's why it is termed as simple. Okay. Now, next one is secured. So Java is best known for its security, right? When you are working with the internet concepts, internet-based concepts like downloading of files, uploading of files, right? So security will be provided by default for using this Java. Okay. So Java programs run inside a virtual machine sandbox. Is that point clear? So it provides a security by default. Next is platform independent. Just before we have learned, program run on one operating system can be executed on any of the operating system. That is platform independent. Is it point clear? That is because of presence of bytecode. Next, we have robust. So, what is robust? Robust is nothing but strong. So, this Java uses strong memory management. Okay, there is a lack of pointers by which the security problems have been avoided. Okay, so this is all about your robustness. Next one is portable. Java is portable because it facilitates you to carry the Java bytecode to any platform. That's what I said. It is platform independent where it is portable. The code written on one operating system can be executed in any of the operating system. Okay, next is architectural neutral. So Java is architecture neutral because there are no implementation dependent features. For example, the size of primitive types is fixed. In C, in C and C++, integer data occupies 2 bytes of memory, okay, and 4 bytes of memory for 64-bit architecture. However, in Java, it occupies 4 bytes of memory for both 32 as well as 62-bit architecture. So, and the next concept here we're going to learn is distributed. What is distributed? Java is also known as distributed because it facilitates users to create distributed applications in Java. We're going to use the concept of RMI, remote method invocation, for creating distributed applications. Okay. Next is multi-threaded. Let's learn. Distributed is done. Now multi-threaded. What is multi-threaded? A thread is like a separate program. A thread is called as a process. We can write a Java program that deal with many tasks. Okay, you can say that as a concept of multitasking. You'll be executing multiple threads, multiple processes simultaneously, which is multi-threaded. That feature is there in Java, which makes Java as what you can say a robust language, right? Next one is you have high performance. So Java is faster than other traditional interpreted programming languages because Java bytecode is the code which made this Java as faster with high performance. Okay. And next you have interpreted. Okay. Then you have all these we have learned, right? So these are the features. I've explained them with all those statements in the above slides. You can see there simple, object oriented, platform independent, secured. Okay, we are not going to use any pointers, so it is secured. Then you have robust, architectural neutral, portable, distributed, multi-threaded. Every point have its explanation, right? Just go through them. You'll find things easy. Okay. Now let us learn about the concept of Java variables. Now, a variable is a container which holds the value while the Java program is executed. So generally, you can say a variable is a container where a value is stored. Let us suppose if I take some value, right? A variable is assigned with a data type. This is called as data type. We have different data types: integer, character, float, double, void, boolean, right? So you're going to assign a variable to its data type. Okay, that will see variable is name of memory location. There are three types of variables that Java supports. Those variables are local variable, instance variable, and static variable. So what is local variable? Name itself suggests local, that is restricted to a block. Okay, so a variable declared inside the body of a method is called as local variable. That variable, the life of that variable is only restricted to that block. Once you come out of that block, that variable dies or life of that variable is stopped. So I can say that local variable is restricted only within a block or within a method, right? The other methods, they don't know even about the variable which is declared in as a local in other methods, right? So this is how generally it goes on. Now, a local variable cannot be defined with static keyword. That is the thumb rule in terms of your Java. Now, what is instance variable? A variable which is declared inside a class. So in Java, you're going to have the concept of class. In that class, you're going to declare a variable. That variables are termed as instance variables. Okay. Now, it can be an instance variable which is created outside the body of a method. Method is nothing but a function. So here instance variables are declared outside the method. Is that point clear? Inside the method, those are called as local variables. The variables which are declared outside the methods, those are called as instance variables. Okay. Now, next one is a static variable, which is declared with a keyword called static. It cannot be local variable. You can create a single copy of static variable and share it among the instances of a class. Okay, instances are nothing but objects of a class. Memory allocation for static variable happens only once when the class is loaded in the memory. That's it. You can't allocate memory multiple times for a static variable. Now, there are some data types in terms of your Java. Just now we have seen integer, character. So these are the data types, okay, which are assigned to a variable. So there are two types of data types, primitive data type, non-primitive data type. In primitive data types, these are few of them, right? Boolean data type, byte data type, character, short, int, long, float, and double. Okay, so now this Boolean generally works with the concept of true or false, right? But by default, if you don't assign anything, it takes as fault. That is false, fine. So we have byte, character, and everything here. These are the data types. So let us see. You can see here, primitive, non-primitive, right? So you have primitive data types, which is Boolean, numeric, Boolean, again, true or false, whereas numeric, it is character as well as integral. Integral, again, it is of integer as well as floating. Okay. Now this integer is byte, short, int, long. These are four subcategories of that integer. Now we have floating point, which you have float as well as double. Okay. So now Boolean, by default, it is going to take false. Default size is 1 byte. Character, this is default value. It has 2 bytes as a specified because it is going to interact with the Unicode concept. Then byte, only 1 byte, short 2 bytes, integer 4 bytes of memory, right? Generally 1 byte equals to 8 bits, right? So if you take 4 bytes, it's nothing but 32 bits of memory is allocated for integer. In the same way, long, float, as well as double, right? This is all about the data types. Next, you have operators in Java. Generally, all the operators which you are using in C, C++, those operators even present in this Java. So you have unary operator, arithmetic operator, shift, relational, bitwise, and bitwise or logical operators, that is less than, greater than, and or logical and, all these operators, ternary operators, assignment operators, equals to, right? So these are all different types of operators present in Java. Now let us come to the list of keywords which are used in Java. Generally, when C language was introduced, it was started with only 32 keywords. But coming to Java, you have total 48 keywords. These keywords are called as reserved words. Okay, so here there are list of keywords which are listed here. Abstract. Okay, we are going to use abstract class, abstract methods. Okay, we are going to use Boolean for working with data type, that is true or false concepts. Then break. Okay, which is used to break the loop or a switch statement. It just breaks the current flow of a program. Next is byte. Next is case. Next is catch. In terms of your try, catch, throw, exceptional handling. Then you have continue. Then default, do, double, else, enumerated. Okay. Next you have extends, then instance of, then integer, interface, new, null, for. So all these are listed here. Okay, import again. This import is generally used in terms of your packages to import. Implements, generally you have extends keyword and implements keyword. Extends keyword is used for inheritance, whereas implements keyword is used to work with interfaces. So what is the purpose of interface? As I have said, Java does not support multiple inheritance, right? So that in multiple inheritance can be executed, or it can be just done or implemented with the concept of interface. Okay, that is the main purpose of interface. Then you have access specifiers, protected, public, private. Okay, so you have all these 48 keywords. Okay, then you have super, this keyword. If we are going to use few keywords to work with the programs as well, that we'll see in coming classes. Okay, now you have Java control statements. So whatever the language it is, we are going to have the control statements. So Java executes code from top to bottom. So Java provides some statements that can be used to control the flow of Java code. Such statements are called as control flow statements. So just you can see what are the control flow statements that are present in Java. Decision making statements. Decision making statements is nothing but I have two things. Let us suppose A and B. I want to check whether A value is big or B value is big. So just I'll take a simple concept like if A greater than B, right? So I'm going to check. I'm going to make a decision here. Either A is big or B is big. Okay, based on my condition, I'm going to print, I'm going to choose anyone. So that can be done with the help of if statement. Then switch case statement, where switch case statement, you're going to have the case blocks. So based on a user defined value, that case block will be executed. For example, I'll say you, whenever you're going to work with the mobile phone, you're going to call a customer care. Okay. In that, if you call customer care, they'll be giving you the options. To know your balance, press 1. To speak with customer care executive, press 2. To know the general things, press 3. Is that point clear? So these options, or go back to the previous menu, press 0. To main menu, press 9. Like this, options will be given. Based on my option, the program will be executed. In the same way, in switch case statement, I'm going to execute the program in terms of case blocks. Okay, based on my choice, I'm going to execute that program. So this is decision. My decision I'm going to make. Okay, next one is loop statement. You have do while loop, as well as for loop, simple things that already we have seen in our C++ as well as C. Then you have jump statement, break statement, as well as continue statement. What is break statement? Whatever the case blocks you have, if you want to come out of that case block, we are going to use this break statement, which terminates or which come out of that particular case block. Then continue statement, which continues the flow of execution of a program. So these are the control statements we have in terms of Java. Then you have few things. I'll say you, these two are called as building blocks of Java. What is class and what is object? So before learning with this class and object are termed as building blocks. Okay, now let us learn what is a class. Class is nothing but group of objects which have a common properties, or I can say that it is a template or a blueprint from which objects are created. Okay, you can create the objects in the class itself. It is a logical entity. It can't be physical. Now I can say a class is a collection of instance variables and methods. Is it point clear? So that is the definition I can give for the class. So a class in Java can contain the fields, methods, constructors, blocks, nested classes and interfaces. Then you have static instance variables. Okay. Then you have final instance variables. Then you have general instance variables. Right. All these can be declared in a Java class. So how to work with the syntax of Java class? You can see here, it is given with a keyword called class, and you're going to give the class name for that. And this is a field. Field is nothing but where you can declare the instance variables, and this is a method. So in the class, you can just declare the fields as well as methods. That's what I said. The first definition, class is a collection of instance variables and methods. Now next one is object. What is object? Object is called as instance of a class. Okay. Now a class is a template or a blueprint from which objects are created, as we have discussed. Now object is the instance of that particular class. Now object is the object in Java is a physical as well as logical entity, whereas class is only a logical entity. Now I can define the object in such a way that object is one through which it can interact with the properties of classes. What are the properties of classes? Generally, classes consist of instance variables and methods. To interact with those instance variables and methods, you are going to use the concept called object. So what is class? How we are going to create object with a simple program? We'll see in the coming classes. Hope this is clear till now. Now, what is instance variable in Java? Okay. So a variable which is created inside the class but outside the method, that we have seen already, is known as instance of a class, or that is known as instance of a variable, right? Or that is instance variable. Instance variable doesn't get memory at compile time. Okay, it gets memory at runtime when the object or instance is created. That is why it is known as instance. Name itself suggests. Now, what is method? Right? Method is nothing but a function which we generally use in C and C++, and it is used to expose the behavior of object. Okay. So what is the advantage of a method, using a method? You can reuse the code, you can optimize the code, you can reduce the code. Okay. Code reusability and code optimization can be done with the help of method in Java. Now, this is an example. As I said, we are going to work with the class as well as object. Now, what I do is I'll explain you this with the output. Now, this is class. And what is my class name? I've taken as student. In that class name, I have declared ID of that particular student and name of that particular student. This is one class, okay, which has only two properties. Student class have two properties, that is ID as well as name. Next is I'm going to create one more class. This is student and this is test student 2. Now in this, see, in this first class, I don't have main function. Now in the second class, I'm going to create a main function, public static void main string arguments, where I've opened this and I need to create the object for that particular class. So generally, in order to create the object, I'm going to use this syntax. What is that syntax? I'll show you. This is class name object equals to new class name. This new is called as a keyword, or it can be an operator, right? So class name. Now I need to access the properties of student class, ID as well as name. So I need to create the object for the student class. So how I'm going to create class name? What is my class name? Student. Okay, next is object. Object is nothing but you can create any of the name of object like S1, S2, OBJ. Okay, so next is new keyword, which gives you the dynamic memory allocation for that particular object. And this is again class name. So you can see here, student object equals to new student. I've created object for student class. Why I have not created object for test class as test student? Because it has no properties. Only student class have ID as well as name. So in order to access the properties of this class, I need to create the object for only student class. So what I have done is, using this object, I'm going to assign the values. S1 dot ID equals to student ID. I'm going to take it as 101. So ID is present in different class. So in order to access this instance variables, I need to take the help of object. So S1.id equals to 101, S1.name equals to Kishore. Okay. So now I'm going to print those IDs as well as names. So this is how I'm going to print S1.id. Right. This plus is called as concatenation operator. What I'll do was, see here, S1.id. S1.id is 101. 101 will be printed. Plus is nothing but concatenation operator, which is going to add whatever I'll give. So this plus and this plus, I'm going to add the space in between. So space will be added, right? And it is going to give you the name as Kishore again after a space. So this plus is going to assign, or it is going to just give some value for a given output, right? It is going to concatenate whatever you give. So here you have given space, that space is concatenated to this ID. Sorry. Is it point clear? So here this is the output which gives you 101 space Kishore. Now in this space, if you write some any of the thing like equals to, okay, that equals to will be printed over here like this. Okay, is it point clear? Now, next one more example I'm going to take here. So there I've taken class as student. Now here I'm going to take the class name as employee. In that I'm going to give the integer ID of that particular employee, name of that particular employee, and salary of that particular employee. Now I'm going to use a method here. Okay, what is method? Generally we have seen it's a function. So I'm going to use return type insert. I'm going to use an insert user defined method. Okay, with int I, 3 parameters, string n, float s. So here I'm going to assign the values I, name, as well as yes. So how I'm going to assign those values, right? I'll just show you. Okay. Then I've declared one more display method. In that it is going to display these things. Fine. Now you can see I'm going to create one more class called test employee. See, this is here I've declared public. Here I have not declared public. By default, this is public. Okay. In Java, by default, it is public. Now I've written a main function. Then I've created objects. 3 objects I've created. Class name, object equals to new class name. Again, class name, one more object E2, new class name, object E3, right? You can create n number of objects like this. But point is, you can't create same object with multiple times. Even see, you have created even here. Again, you can't create even here because Java is restricted with creation of multiple objects with same names. So you need to give different objects. Okay. Now even dot insert, I'm passing the parameters here. Insert is a method where I've taken 101 is my ID, Anil is my name, and this is my salary. So these are passed as parameters to this function for the first time. So now ID is 101, then name is Anil, and salary is 45,000. Then it is going to display that ID, name, as well as salary. So first ID, name, and salary is displayed. Is it point clear? Now the same with E2. Second time I'm declaring one more, I'm calling one more function with different parameters, 102, Akil, and 25,000. Again, it goes to this point, right? And it is going to print all these 3 values again. It is going to assign them and it is going to print them. In the same way for third variable, third object as well. So you're going to call display, display, display. You can say e1.display, e2.display, e3.display. Display is a method which displays. See, first of all, it is inserted. When you call e1.display, it will be executed, e2.display. Now other E2 employees will be, see, E1 holds only these 3 values, 101, Anil, and 45,000. E2 holds these 3 values. So whenever you say E1.display, all the values present in E1 are displayed. Whenever you say E2.display, values present in E2 are displayed. Whenever you say E3.display, values present in E3 are displayed. Clear? So now generally method we have seen, right? So how we are going to create method? So this is how the structure is. In general, a method is a way to perform some task, right? Similarly, a method in Java is collection of instructions that perform a specific tasks. Okay, the main functionality or main advantage provided by method is it is used for reusability of a code, right? We can also easily modify that code using methods. So how you are going to create method? So you have this concept, this is syntax. Okay, access specifier, int, this is data type. Okay, or return type you can say. This is a method name. This is parameter list. So public void, generally I'll say return type as int, void, whatever it is. So this is the way to you declare a method. Okay. And this is the body of the method where you're going to write the content or instructions or execution part in that particular method. So this is how you're going to declare a method in terms of your Java. Now, if I compare this for the previous one, you can see here, you have this method. See here, void insert. I said, if you don't assign anything by default, it can be taken as public. Public void insert. Public is access specifier, void is a return type, insert is a function name, and this is list of parameters. Okay. The same thing in terms of your method declaration. Clear? So this is all about which we have seen. You can see here public. We have four types of access specifiers. So what is access specifier? It is also called as modifier. It generally specifies the visibility of a method. Now you can see we have public. So the instance variables and methods which are declared with public access specifier, they can be accessed inside the class and they can be accessed outside the class. Okay. So private, when you declare instance variables and methods using private access specifier, they can be accessed only inside the class. They cannot be accessed outside the class. So in order to access private instance variables, definitely one public method is must. Okay, that we'll see with the example. Okay, they can't be accessed outside the class. Now protected, when you're using this protected access specifier, they can be accessed inside the class as well as outside the class, but there are some restrictions, right? When you come to the concept of packages, okay, or for subclasses, there its accessing procedure will be different. Now next one is default. So in the previous section, we have learned what is default. That is, you're not assigning any value. By default, they are using it as public because it is visible. So visible is nothing but generally you're going to use public. By default, Java is public to package. Clear? Now you have the concept of type conversion. Okay, that we'll see. Now you're going to learn two different and important concepts of Java, that is type conversion, okay, and typecasting. So the name itself suggests what is conversion. You're going to convert one type to another one type to another type, right? So typecasting refers the same, but there is some logical difference there. I'll say you type conversion generally it is a process in which a data type is automatically converted to another data type. Int can be converted to float, right? Float can be converted to int. Okay. The compiler does this automatic conversion at compile time itself, right? So data type to which the conversion happens is called as destination data type, and the data type for which the conversion happens is called as source data type. If I take an example, you can see here, I've declared a class called main. In that, I've declared a main function. I've taken int a equals to 20. Now the value of a is 20, which is of integer type. Now float is higher data type than integer, right? So I'm going to convert this integer to float. When I say float b equals to a, which is nothing but a is an integer data type, which is stored in b. It will be converted into float data type. A value now it is converted into float data type and it is stored in B, right? Now, if I print the value of A and B, A will be printed with A because A is integer and B is a float variable. So it is going to print with 20.0. Okay. So now what generally we'll do in type conversion is, okay, the destination data type must be larger than the source data type. Okay. Now, what is source data type here? Integer. Now, integer occupies 2 bytes of memory, right? And float occupies 4 bytes of, sorry. In terms of Java, it occupies 4 bytes of memory, whereas it occupies again 4 bytes of memory, right? So now, in this integer, again, you have the short integer byte, like you can see here, byte, short, followed by integer, then long, then comes with float, then comes with double. So now what you do is, whatever this integer data type is there, okay, that is larger, that should be uh, less comparatively to your float data type. Is it point clear? Now you can see destination data type must be larger than the source data type. So destination data type is this one, right? Where source data type is this one. Okay. So here this byte short also given with 2 bytes of memory, where this 2 bytes is less than comparatively your 4. Is that point clear? So that's the reason you're going to work with this type conversion. Okay. Now the same thing with typecasting. It is also a typecasting. It is also a process in which programmer manually converts one data type into another data type. Okay. Now you can see it is quite opposite comparatively here type conversion. In this, the source data type with a larger size is converted into destination data type with smaller size. Now you can see double, it's of 8 bytes of memory, right? Integer byte, integer is 4 bytes, byte is 2 bytes. Is that point clear? A byte is 1 byte, sorry. Okay, it can be 2 bytes, 3 bytes, whatever it is. So what I'm doing is I'm just converting one data type which is of higher to lower data type. The same thing. I've created a main function int a equals to 20. Now what I'm doing is short b I've taken. I'm just putting this a into short b. I'm going to print the value of a as well as b. Now you can see 20 and 20. Right? Integer which is of larger size is converted to short, which is of smaller size. Is that point clear? You can see here, a is integer, but what I'm doing here, I've converted that into short and I'm assigning it to short b. So this is how we are going to work with the concept of typecasting. Okay, now in coming classes, we are going to learn few important concepts, that is constructors, inheritance. Okay, so abstract classes, interfaces, very, very important, and related to some important keywords like this keyword, super keyword, final keyword. All these we are going to learn in the coming sessions. Hope this is clear till now. Thank you all.